can be defined as displacements. Okay, so both of them basically has the same units, but of distance and displacement, it doesn't matter. Okay, by the way, these questions ask for work does. Okay, and we know work formula equals to force times cos theta if there is an angle between the tension and horizontal component. Yeah, don't forget multiple by a distance. Okay, and force equals to 100 and cos theta cos 30. Cos 30 is 100 root of 3 and the distance is 5. Okay, and if you calculate this number by one, by the way, you will obtain the result of 433 joule. 433 joule. Okay, so from all of these choices, yeah, the best one is C. Okay, I think these easy questions. Yeah, I hope you answered this correctly. Number two, yeah, number two, as you can see, the gas in an engine does work on a piston of cross-sectional area 80 centimeters square. The pressure on the piston has a constant value of, okay, so what is this? The units is Pascal. So we can assume this is a pressure. Yeah, the pressure is 4.6 times 10⁵ Pascal. And then the cross-sectional area is 80 centimeters square. And please convert this unit first before you substitute into your calculation. Yeah, don't forget centimeter square to meter square is time minus 4 meter square. Okay, and what is this? This is can be a distance or displacements. Yeah, d. Wait. Okay, and the displacement or a distance is 25 centimeter, and convert these units, yeah, into meter. 25 times minus second meter square. Okay, so these questions ask for the pressure. Oh, the units of multiple choice is joule. So this we can assume the questions ask about work. Yeah, work. Okay. Nah, work of gas. Yeah, I told you the way how to determine work of gas. Yeah, basically work of gas can be calculated by this formula, which is work equals to pressure times the change of volume. Nah, but we don't know about the volume yet, so we have to find the volume first. Yeah, and the change of volume can be calculated use this formula. The cross sectional of this area, we got both of them. Yeah, firstly the cross sectional area is 80 times 10⁵ 45 10 minus second. Yeah, and if you calculate this number, you will obtain the result of 200 2000 times 10 minus 6. Yeah, or maybe we can write this equation as 2 times 10 minus third. What is the units of volume? The volume unit is a meter cubic, of course. Okay, and then after you obtain the delta V, you can substitute this number to this formula. Yeah, the pressure is 4.6 times 10 positive 5 times 2 10 minus 6. Eh, I'm so sorry. This is supposed to be 3. Yeah, minus 3. Okay, and then multiple the number 4.6 times 2, you will obtain the number of 9.2 times 10 second positive. Okay, joule. This is so obvious. Yeah, the choice is A. Okay, yeah. The maximum number 3, the maximum useful output power of car traveling on the horizontal road is P. The total resistive force acting on the car is, okay, resistive force. So we can write the symbol F equals to kv square, where v is the speed of car and k is constant, which equation is correct when the car is traveling at maximum speed. Okay, I told you about the formula of power. Yeah, basically there are many equations in order to calculate power. Yeah, one of them is force times velocity or speed. Okay, yeah. By the way, uh, this question said that the force, the resistive force, equals to constant times speed square. Yeah. So we can substitute this variable to this equation. And by the way, the definition of phi, this phi and this phi equals. Yeah. Both of them are a speed of car. So this means you can multiple this variable by this variable. So this equals to, nah, okay, so the best, oh, you just make the equation like this. Okay, yeah, and then we choose A for the best answer, number 3. Okay, basically there are many equation of power. Yeah, I told you. Firstly, the power can be defined as work per unit time, and then you can derive this equation, and you will obtain the formula, the other formula of power. Yeah, okay. So sometimes you can use this to solve the problem, or sometimes you must use this. So this likes conditional, depends on information you obtained from the question. So I hope you read questions carefully. Yeah, watch the questions word by word. Yeah, Don't read the questions too fast. Okay. Next, and I think about problem number 1 until number 3. Yeah, those are like easy questions. Yeah, you don't need to think too hard to solve about those questions, and I hope all of you answer it correctly. Okay. Nah, number 4. Some gas in a cylinder is supplied with thermal energy Q. Okay, thermal energy Q. Okay, the gas does useful work in expanding at constant pressure. Wait. Thermal energy equals to energy. Okay. The gas does useful work in expanding at constant pressure P from volume VO to volume VF. I shown this figure, which expression gives the efficiency of this process. Okay. Efficiency basically equals to power output per power input. And power itself can be defined as work per time. Okay, work per time with uh, yes, work per time. So we can substitute this variable by this formula. This means uh, energy out per time per energy in per time. Nah, and we have to assume that the time are equal, yeah, between this time. Okay, so we can omit this time, yeah, and then the variable only left uh, out. Sorry. Yeah, out per in. Nah, this is about gas. Okay, about gas. So you have to remember how to find work of gas. Yeah, and we have discussed at previous questions, yeah, how to find work of gas. Yeah, work of gas can be calculated by this formula. Yeah, pressure, time, change of volume. Change means final volume minus initial volume. Yeah, from this equation, from these questions, it's so obviously that the final volume is Vf and Vo means initial volume. So this means Vf minus Vo. Okay, and from these equations, yeah, these questions taught us about the supply with thermal energy Q. Yeah, this means supply. Supply means the energy enters the piston. Yeah, or in other words, you can say as energy input. Okay, input Q. So it's we just change this variable to this variable. Okay, yeah. So this is the efficiency of these pistons. Pressure times change of volume divided by Q. Okay, so the best is C. Yeah. Number 5. By the way, after I discuss all of these questions, is someone feel still feel confused about my explanation? If you have just asked uh, whatever, yeah, and whatever the things makes you confused, but if you understand, yeah, we continue to this question is thrown. Okay, let's read this first. Mass is 0.3 kilograms, is thrown vertically upward from the ground with the initial velocity of 8 meter per second. Okay, initial velocity, this means lap. Yeah, the object reaches a maximum height of, okay, the maximum height is 1.9 meter. How much work done is done against air resistance as the object rises to its maximum height? Okay, firstly, let's draw the condition of this. Wait, yeah, wait a minute. Okay, nah, let's draw about this condition. So firstly, there is a ball, yeah, and this ball is thrown vertically upward. So this is the direction of ball motion, yeah, and then this ball uh, reach maximum height. So let's say before this ball reach maximum height, yeah, let's say this is ground, okay, and then there are two forces x on this ball. What those are? They are uh, weight force, yeah, and then the second force is resistance force, yeah, resistance force. Remember that the resistance force always in opposite direction with its motion. Yeah. So what is the force to the upward? No force direction to the upward from this case. Yeah. Only two force. Yeah. X on the ball. Those are weight force and resistance force. Yeah. So this is just a symbol of motion of this ball. Yeah. The direction is velocity. Velocity is not uh, included into force because the units of velocity is different. Yeah, the velocity of the units of velocity is meter per second. Meanwhile, the units of force is Newton. Nah, both of them include into force because, yeah, as we know, the units both of them are the same, Newton and Newton. Okay, so only two forces, X and force, and both of them direction to the downward. Okay, so I hope you get what I mean. Uh, no force direction to the upward. Yeah, only two forces to the downward. Yeah. Nah, Okay, so our goals here want to know about work done against resistance, air resistance. Okay, now uh, I told you the formula, yeah, the formula. We cannot use uh, mechanical energy because there is a resistance of air. So we have to use the others formula. The others formula is W equals to change of kinetic energy. Change kinetic energy means kinetic energy final minus kinetic energy initial. And as we know, the work itself is sum of forces x on the ball times the distance or the displacements. In these questions, the displacements equals of the height. Yeah. So I can read here. Arias asks for work is done against air resistance as the object rises to maximum height. Remember, when the ball reach maximum point, this means the final velocity equals to zero. If the final velocity equals to zero, it will evac to the kinetic energy final. Because the kinetic energy formula is 1/2 mass velocity square. If the velocity equals to zero, the kinetic energy 0 too. Yeah. Nah, sigma F. Sigma F, I told you only two forces and both of them direction to the downward. Okay, so we have to make assumption that the downward force equals to negative, meanwhile the upward to the positive. But in these questions, no force to the upward, only two force to the downward direction. Okay, so we can read here minus weight force minus F resistance times the height. And then mm, multiple, wait, text, I want to take out the minus symbol because both of them has the minus. Yeah, so the equation will be like this. Minus 1/2 mass velocity initial square. So we can omit the minus. And then let's multiply h one by one. Yeah, with force times height plus F resistance times height equals to 1/2 mass velocity initial square. Nah, remember the formula of work. Work is force times the displacements of or the distance. Now, I think this is the work of resistance, our goals. This is our goals. Yeah. And then you just substitute the number you knew from the questions. Yeah, weight force means mass times gravity. Okay, the gravity is 9.8, yeah. Or if you by the way, it doesn't matter if you use 10 for the gravity, yeah, because the result will be similar. But if you are in real examination of Cambridge, you have to use the number of 9.8 for the gravity. But in my lecture of our lesson, yeah, our unit test or another assignment, if you want to use 10 for gravity, it's okay. But remember, you have to use 9.8 for exam for the real exam of Cambridge. Yeah. Now in this solution, I want to use the number of 9.8. Okay, 0 0.3, 9.8, and the heat is 1.9 plus work of resistance air. Yeah, one half 0 0.8, and the velocity is 8 meter per second square. Okay, and then let's calculate this one by one. Wait a minute. 0 0.3 times 9.8 and then times 1.9, we will obtain the number of 5.586 plus work of air resistance and then 9.6. So this means the work of resistance equal 9.6 minus 5.58 meter 86, and then you will obtain the number of, wait, 4 point, okay. So let's see about the question, the option. Okay, so the option is A. Yeah, so that's all about number 5. You have to analyze first what information told by these questions. Yeah, and then you write the information that you know from the questions, and then you have to draw a figure of this case, yeah, in order to know the direction of force, and then you have to analyze which one from all of formula you know that can help you solve this problem. Okay, like this case, I use this formula, yeah, to solve this problem. Okay, nah, so that's all about number 5. Let's continue number 6. Okay, nah, actually, no, no. I hope, yeah, in your work paper, yeah, I hope you wrote the reason why you choose this option. For an instance, let's say you choose B, so I hope you write the reason, yeah, and the reason I hope consists of your calculation, yeah, in order to prove that your reason is uh, makes sense. Okay, nah, like number 6, two boxes X and Y have the same mass. Box X is lifted, yeah, vertically through the head edge by a force of magnitude F, and then box Y is pulled along a slope by a force of the same magnitude to reach the same height, as shown which statement is correct. Nah, force and this force are the same, yeah, height and the height are the same. Okay, so let's read all of these option, yeah, in order to to know what is the questions of this problem. Both of boxes gain amount of potential gravity. Okay, so basically all of these questions ask about potential energy and work done. Okay, nah, actually, if we talk about energy potential, energy potential only depends on heat, yeah, m gravity heat, and then m gravity h, and both of them are the same. I mean the heat of x and y are the same. So this means the potential energy between x and y are the same. Yeah, because the heat, yeah, is the same. Okay. Nah, so this means the C and D option are wrong. Yeah, only two left option. Those are B and A. Okay. Nah, the same amount of gravity potential energy, and let's discuss about work. Nah, work is equals to sum of force times heat, yeah, and then this is sum of force times distance, yeah. For y, the work depends on the track, yeah. Let's say this track from the bottom to the top, okay, not depend on the heat, but the X box, it's depend on the heat. Okay, and let's talk about the forces. What are the forces acting on this box? There is a force to the upward, and then weight force. Okay, there are only two forces act on this box. Those are force and then the weight force, and both of them have opposite direction. Okay, so this means you can read here force minus weight force times the heat. Meanwhile, the X box, yeah, and the Y box is W sin theta. Okay, so this means the total, the sum of force is F minus W sin theta times S. Okay, yeah. So what is the correct, A or B? Now I think it's so hard to find which one is correct. Yeah, if you not use a number, so we can assume you can use your own number. So you can make your own number. Yeah, for an instance, like me, I I want to assume that the force are the same and the heat are the same. So let's make assumption that the force is uh, 10 newton. Okay, so this means the force is equals 10 newton, and then let's say the heat is 3 meter. Yeah, so this means the heat of this is the same, 3 meter, and then the mass of the box is 1 kilogram. Let's say the gravity is 10, yeah, and let's calculate this one. the force is 10. No, 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 no. I think 20. Okay, let's substitute 20 minus 10 times 3. This equals to 30 joule. Okay, how about this? Okay, so 3, let's say this is 4, yeah, 3, and this means the distance from bottom to the top is 5, yeah. F equals to 20 minus 10 sin theta. Theta means the opposite divided by the resultant, yeah. 3 per 5 times 5, okay. 20 minus 6 times 5, okay. 12, 12, 14, yeah, times 5. So this equals to 70 joule. Now, from this calculation, as you can see, this means work done from Y box is uh, higher, yeah, than the work done on X box. Okay. Now this means the statement of A optional is wrong, yeah, because it said that the same amount of work. Okay, so this wrong. So the best choice is B. Yeah. But more work is done by the force acting on the box Y than by the force acting on box X. And this is correct. Yeah. We have shown with our calculation. Yeah. We use the number, our own number. Yeah. We can assumption and we obtained our final result, and it said the work of X is 30, meanwhile the work of Y is 70. This more than X work. Okay, yeah. So that's all about number 6. Okay, let's continue number 7. Leonardo da Vinci proposed a flying machine that would work like a screw to lift the pilot into the air. The screw is rotated by the pilot. The machine and the pilot together have a total mass of, okay, the mass total is 120 kilograms, which use full output power must the pilot provide to move vertically upward a constant speed. The power. Only two variables we knew from these questions. Those are mass and then velocity. How we find the power? Use this are variable. I told you the power can be defined as force times the velocity. Okay, and I hope you understand, yeah, if the questions only told you about the velocity and asked about the power, so I hope you connect with this formula. Okay, power equals to force times velocity, and the force itself can be calculated use this formula. Okay, the mass is 120 and the velocity is 10 and the velocity 2.5. So you will obtain your number of watt. Okay, so the closest one is this option. Yeah. Number 8. Mhm. I think number 8 is the same like number 5, because this seems we will use the same way with number 5. Yeah, because in these questions, yeah, in these questions, what is the energy dissipated by frictional force when the car moves x to y? Yeah, basically the questions is the same as number 5. Yeah, this means we will use the same way in order to find energy dissipated by frictional forces. Okay, we use the same formula. Yeah, work equals to change of kinetic energy, and change means final minus initial, and then the work is the sum forces acting on this car times the distance. The distance means x from y. Yeah, x to y, and 30 meter is heat. Yeah, is heat. And sure, of course, the distance and the height are different. Yeah, even though the height is 30 meter, it doesn't mean the distance is the same as height. Yeah, the number will be different. Okay, so from this figure, it's so obvious. The speed initial equals to 0, so we can omit this one. Yeah, and then the forces acts on this car. Yeah, remember what is this? This is W sin theta, and we don't know about the theta. What else? Of course, the force of resistance. Okay, the frictional force. And as you can see, the direction between W sin theta and frictional force is in opposite direction. So we have to make assumption that the direction to here is positive, meanwhile the opposite direction will be negative. Okay, and then let's substitute these variables to this equation. W sin theta minus frictional resistance times the distance equals to 1/2 mass initial velocity square. Okay, let's multiply this distance one by one. Yeah. Okay, and this equals to W sin theta times S. S means distance. Yeah. Usually we use D. D minus F resistance times D, and then 1/2 mass. Okay, so how we find about sin theta? Because these questions only said about the height without give us about the distance. So remember, sin theta is the opposite per hypotenusa. Yeah. So this means W equals to height per D. This is sin theta. Yeah, times D minus F times D equals to work of resistance. Okay, 1/2 mass initial velocity square. So this means we can ignore this one. And this is weight, yeah, weight of car. The mass of car is 500 kilograms. This is the weight of car is 5,000 Newton. 5,000 times the height is 30 minus resistive resistance work equals to 1/2 times 500 initial speed. Sorry, this supposed to be a final speed, yeah, because the initial speed is 0. Final speed is 111. 11 square is 1 to 1. This equals to and then and this equals to 30 to 150. And our goals is want to know about the work of resistance, and this means 150,000 minus 3,250, and then you will obtain the number of 119,750 joule. And this number close to 120,000, yeah. Okay, yeah. And then let's check the option. Okay, so we obtain the number of this, yeah, 100,000. Yeah, this equals to 1.2 times 10 5 joule. Okay, so basically we use the same way, yeah, as previous questions. Okay, let's continue number 9. Okay, as you can see, an object is moved in a vertical plane from x to y, x to y, then from z to y, z, y to z, sorry, y to z, okay. The distance between various points are indicated on the diagram. Lines x, y, and vz are vertically. The object weight 20 Newton. How much gravitational energy does the object gain by moving x to z? Okay, remember, potential energy equals to mass, gravity, and the height. Okay, basically, x to z, from v to y, sorry, to z. Okay, remember, energy potential only depends on the heat. Okay, we don't care about this distance, yeah, we only see about this heat. So basically, yeah, this is the weight, yeah, the weight is 20 and the heat is 3. Okay, yeah, remember, even though you draw a line from z to y, yeah, and you find this number, let's say this number is not useful, yeah, because energy potential only depend on the heat, okay, the heat of system. So we still use the number of 3. Okay, the last one, by the way, there are 12 here. Okay, let's check number 10. Okay. I think we can discuss these questions next week, yeah, because our time almost up. So it doesn't matter if we discuss these questions next week. Okay, I think that's all about today. I hope you understand what I explained. Yeah, and if you